Hey guys, welcome to the homework number 11 video. It is fourth period on an A-day, so if you're trying to stop by, the sign is now in the window that recording is in session. So that's too bad for you, I'm very sorry. But anyways, let's get started on the homework number 11 video. So as per our new homework protocol, I'm going to be doing the problems in this Google Classroom section. You don't have to watch every problem, but if you have a question, this is a good time to see how to solve each of these problems as an example. And in the column on the right, that's where you get to try. And the problems are very similar to the ones that I'll be doing on the other side. So let's look at number 10. In case you didn't notice too, these are all ACT problems. So once again, this is good practice for the ACT as well. So the figure below shows lines AB and DC, line segments AC and BC in two angle measures. What is the measure of angle ACB? The good thing about the ACT is a lot of times they'll provide you with a labeled diagram, which is awesome. So now we just have to find this angle. So what I would do, I notice first of all that these two angles are supplementary, which means that they have to add up to 180, right? Same with these angles over here. So I'm going to use the fact that a straight line equals 180 degrees to figure out this angle and this angle. So I'm going to take 180 minus 132. That gives me 48. Hopefully we can see that. That's 48 degrees right there. Over here, I'm going to take 180 minus 103. 180 minus 103 is equal to 77. So now I need to know that I'm looking for this angle, right? And I know that the sum of the angles in a triangle equals 180 degrees. So if I take 48 plus 77 plus x, because I don't know what this is right here, that should all equal 180 degrees. I'm going to put 77 plus 48 in my calculator. I get 125 plus x equals 180. I'm going to subtract 125 from both sides. X equals 180 minus 125. That gives me 55 degrees, which is answer choice J. And I think that's also what I got when I was doing this not live, so that is a good sign for me. So if you have any questions, please come talk to me or Miss Avra. Otherwise, we are moving on. So problem number 18, in isosceles triangle ABC, line segment AB is congruent to line segment BC, and the measure of the vertex angle, angle B, is 75 degrees. What is the measure of angle A? So first thing I would do is it tells us we have an isosceles triangle and we don't have a diagram. I'm going to draw one. We all know that my handwriting isn't the best, so I know that this is going to be the two sides of my these are going to be the two sides of my triangle that are going to be part of the isosceles. So it tells me that line segment AB is congruent to BC, so that means that I want AB to be the same thing as BC. So I just labeled A, B, and C according to this line right here. So the measure of the vertex angle, which is angle B, is 75 degrees. So I know that angle right there is 75 degrees. So it wants to know what the measure of angle A is. So that means I'm looking for this one right here. Well, if I look at my notes from this class today, I'm going to see that when I have two sides that are the same, marked by these straight lines through the middle, that shows me it's an isosceles triangle. This angle right here is going to be the same as this angle right here. So if I call this x, this one on the other side also has to be x because they're the same thing. I also know that the sum of all of the angles in a triangle is equal to 180. So if I take 75, which is angle B, plus x for angle A, plus x for angle C, that's all going to equal 180. So if I take 180 minus 75 from both sides, like a good math student, I'm going to end up with x plus x equals 105. If I combine like terms, 1x plus 1x will give me 2x. 2x equals 105. Divide both sides by 2. X equals 105 divided by 2, which gives me 52.5 degrees. The question was asking me for angle A. Angle A is equal to x, which is equal to 52.5 degrees. That is answer choice H. Once again, if you have any questions on that one, please come talk to me or Miss Avra. The important part about this is that the angles in the isosceles triangle at the bottom of each of those two congruent bases are the same. Also, if you are paying attention and have your notes out in front of you, you're going to notice that this is following our notes very similarly here. Question 1 shows us the angle measures of a triangle. Question 2 is about isosceles. So I wonder if that's going to continue with this pattern with the area. And what do you know? Shocking to all involved, I'm sure. So we have the side lengths in centimeters of right triangle DEF are given in the figure below. What is the area of triangle DEF? So first of all, we have to remember that the area of a triangle is equal to base times height divided by 2, or 1/2 base times height. Those are the same thing. So if I'm looking here, my base is going to be the part on the bottom, which is 16. So I'm going to have 16. My height is going to be how tall my triangle is, which is this one. And I'm going to divide all of that by 2. So I have 16 times 12 divided by 2. I'm going to do that on my calculator right over here. 16 times 12 divided by 2. That gives me an answer of 96, which is what I got before as well, which is great. Notice, and this is kind of how I like to think about it too, we did not use our hypotenuse because that is neither a base nor a height. So that's not something we have to worry about when we're thinking about the area. Last question, I wonder if this is going to be a Pythagorean theorem and if it'll keep following our notes. And again, plot twist, it is super exciting. So one leg of a right triangle is 4 meters long and the other leg is 8 meters long. The hypotenuse of the triangle is how many meters long? So once again, I don't have a diagram on this one, so I'm going to draw it out. So I know I'm going to draw a right triangle because it tells me that right here. So I'm going to make that my right triangle. So one leg is 4. It doesn't really matter which one. The other one is 8. So I'm going to label each of those sides. I'm looking for this. So a reminder that my Pythagorean theorem is a squared plus b squared equals c squared. So let's fill in those. So this is going to be a, one leg. This is going to be b. And reminder that c is always going to be my hypotenuse because, as people pointed out today, the hypotenuse is always going to be longer than either of my 2 legs. So it's really important that c is that hypotenuse. So now let's fill in what we know. I know that a is 4, so I'm going to do 4 squared plus b and 8 are together plus 8 squared equals c squared. You can either put this in your calculator right away, do 4 squared, which is 16, plus 8 squared, which is 64, so that would give us 80 equals c squared. I like to get c by itself first, so I'm going to take the square root of both sides. So I'm going to have c equals the square root of 4 squared plus 8 squared, and I can put that right in my calculator. I'm going to tell you right now it's a square root of 80, but that's okay. So we have the square root of 4 squared plus 8 squared, which is 8.94427. Because that's not an answer choice that comes up, I can either compare them all, or I could just take 4 squared plus 8 squared. That gives me 80. It's going to be the square root of 80, which is answer choice K. So either way, if you want to see which one of them works as a decimal, whichever way works. There's basically a bunch of ways you can do it, but that is the most common. So that concludes our front side video. If you have any questions, please come to talk to me or Miss Avra, but this is very similar to what we did in class today.